I'm going to try something new and try to hold this umbrella the whole talk, so we'll see how this goes. Thank you for the introduction. Yeah, I'm Stephanie. I just moved to Berlin a few weeks ago, actually, so if you're in Berlin yourself, hey, come say hi to me. I need to make new friends. And before that, I was living in Amsterdam. I just started a new job. I'm a software engineer at Microsoft, and if you didn't know, Microsoft has a really great to-do app, and that's what I'll be working on. And I also love front-end, CSS, React, and accessibility, so feel free to come and talk about any of those things, or if you just want to talk about LEDs, we can do that too. So as you could probably already tell from my getup here, I really like to build fun things with LEDs, but I didn't know that I really like to build things with LEDs until recently. And this is my dog's son, Wilbur, and don't mind the poker face. He actually really loves LEDs, because who doesn't love to put on LEDs because you go out with LEDs, and he gets lots of attention, and everybody thinks he's like the cutest dog in the world. So. So, yeah, I really like to build fun things, but I'm also a hardware newbie. I've only been working with hardware for the past year. And I didn't really get inspired by other projects. I actually got inspired when I was living in Amsterdam, and I went to this art museum. This is the Stedelijk Art Museum. It's a modern art museum in Amsterdam. And I went to see a specific exhibit of art there. I went to see this exhibit by Jean Tinguely. If you're not familiar with him, he's a Swiss artist. He didn't do anything with LEDs. He's from the 60s and 70s. And he made these mechanical art pieces that could be triggered by a viewer and would create art themselves. And for him, art was not about standing in a sterile white space and silently gazing at a painting. It was meant to be playful. And the viewer's experience was really integrated into the overall effect of the work. It was meant to be interacted with. It was meant for the line between the artist and the viewer to be blurred. And like in this piece, the viewer is invited to choose a drawing tool like a pencil or a crayon, put it into the holder on the installation, and then when it's put into motion, it would just create its own original piece of artwork itself. So it was no longer about just watching a process. It was, by including the viewer, they play a central role in the creation of a new piece of art. And when I was there, there was this quote, and I'm going to read it now. It says, "I wanted something ephemeral that would pass like a falling star. The work just had to transpire, make people dream and talk, and that would be all." And this really stood out to me, because I really like this idea of art as a temporary experience that connects an artist and a viewer. And it's just spontaneous, and it lasts for a short amount of time. But in that time, it's just really playful, and it just brings joy to the viewer, the artist, and the people around. And I got really excited about that. And I wanted to figure out a way to use my skill set as a developer and make some kind of interactive art experience myself. But when I was living in Amsterdam, I was living in a really tiny studio, and I didn't really have the space to dream up a big mechanical installation myself, just because I didn't have the room for that. So I decided to apply the same idea of interactivity to the most accessible form of expression I could think of, which would be my clothing. And I don't want to leave you in suspense. You can see some of the things I made. But I made a complete outfit with this umbrella, necklace, and skirt, and because I really wanted it to be a cohesive, complete look. And it's completely interactive via a web app. And I was really interested in taking this out and seeing what would occur when people realize that they actually could have complete control over how my clothes would look. So I came up with a project plan, and first I wanted to create a web app so the users could just go to a URL and make some selections and then change how it looks. Then I needed to actually build the pieces, so I needed to integrate LEDs and microcontrollers into clothing. And then I needed a way to get those messages from the web app to the hardware so it would know what it needed to do. And for me, I instantly thought of Socket.io. If you've never heard of Socket.io, it's just a library that makes it really easy to do event-based messaging. It works in all. What's great about it, it works in all browsers and devices. And you just really create like you can create a node server and include like the Socket.io server library, and that would relay messages to client libraries. So I had all this stuff figured out, so it was going to be easy, right? No. So I wouldn't have a talk if it was easy. So I actually faced a lot of challenges. At first, I thought my challenges were going to be just strictly like the building, like the wiring and the soldering, because it was really the most ambitious hardware project I've ever done. Yeah, and just main takeaway is, building stuff is all about iteration. I had a lot of setbacks that made me really unsure if I could do this, if I was capable. And I got frustrated a lot that I was just going to be a terrible maker and I never was going to get better at this stuff. But I just kept trucking along and trying to learn through all those setbacks and continually improve my project, and I'm going to share those with you now. So I'm just going to start at the beginning. So I had the plan. I needed. I knew that I was going to create a simple web app, and where users could choose colors and different light programs, and those I would just integrate a Socket.io client in, and then I would have a Socket.io server that would relay those messages from the app to the hardware. And then I'm not a DevOps magician, so I was just going to deploy this all with like a simple Express server on Heroku, because Heroku is really easy to deploy and set up things online. So I really didn't think too much about the software side of the project at the beginning. I was mainly focused on the hardware. So I had some limitations. So since I was going to put this in clothing, it obviously needed to be like a really small footprint, and it also needed to be, just really discreet so it wouldn't be this clunky board in my clothing. It also needed to be durable because it's clothing and jewelry, and I would be taking it on and off, and I wanted to have some kind of a lifetime. And it also needed Wi-Fi connectivity because that's how I was going to communicate these messages from the web app, from the server, and then to the hardware. So I picked this microcontroller. It's Adreno. It's small. It has Wi-Fi built in. And the main selling point was it has a lot of support. There's a lot of people building stuff with it. So I could find a lot of tutorials or documentation to help me along the way. So once I did that, I just really started building. And if you've never worked with hardware, you might think it's like this glamorous process, but I want to debunk that and show you that, and I see that people already know the URL, so that's great. This is me in my studio in Amsterdam, and it's not really glamorous. It's just me like soldering and sometimes burning my fingers and just assembling stuff together. And I wanted to give like a tip. If you ever decide to build something, making wiring diagrams before you start soldering stuff is very useful, and I highly recommend it. There's tools. This is on Fritzing. It's just a free tool, and it has plugins where you can get different like LEDs that's like my LEDs for the umbrella. You can see in all the wires, and just to kind of keep you're cool while you're building and kind of have a roadmap, because it can get pretty hairy when you have all these wires on the floor and you mis-solder them, and then you have to unsolder them, and you don't want to do that. And then I wanted to create kind of this experience where I didn't have that much interaction when I took it out. I didn't want to have to like give an explanation to people. I wanted them just to kind of experience first. So I made up these cards just to hand out, because I would have lights on, but I didn't want to really answer a lot of questions, so I just handed out cards with the URL on it. And I want to talk about the first time I took it out. So I took it out last December in Amsterdam. They have a lighted bike ride, which is a lot of fun. People just put LEDs on their bikes, and I decided to make this whole outfit for it. And I want to show you just a video clip from it. So everything's working great. And then if you notice my skirt, the light goes green on it. Yeah, that's my skirt rebooting. That was not supposed to happen. And yeah, I was like petrified because I had spent so much time working on this, and then I felt like I was apologizing all night for like my skirt or my umbrella or my necklace kept like crashing because they're all supposed to be synced up, and people still thought it was amazing, but all I could see was like all these problems and it wasn't working properly, and yeah, it was a fail for me, and I was just so embarrassed by that and disappointed. Even though people thought it was amazing, it was not what was supposed to happen. So I just, I picked myself up from that experience, and I decided, I was going to try to figure out why it was crashing and to make this work better, because I just wasn't satisfied at all. So luckily for me, this particular microcontroller, that Feather HISA, you can do some like console logging through like your USB cable. So I just did like what I do a lot in JavaScript, is just put a lot of console log statements to see where in the program it was having issues. And what I found is it kept crashing because the Arduino was having trouble staying connected to that Socket.io server. It just kept disconnecting and reconnecting again, and that's why it would crash and it would start up, and it would just start up on like the default program. And that just started making me think about the tools I was using. So Socket.io is really great for the web, but was it really the best for my IoT project? Web, you're communicating usually over HTTP, and this Socket.io is really geared towards browsers, and I'm just working on hardware. Do I really need all the extra overhead? And yeah, I would just say, just because the library is available and it's awesome doesn't mean it's necessarily the best solution all the time for your projects. So I just took a step back and I thought about, working with hardware, like really what are my priorities there? So coding for hardware, so resources are really at a premium. There's only so much memory on hardware because it's got a really small footprint. So I wasn't communicating between a browser and a server on hardware, so I really didn't need that extra overhead for HTTP. And just really need to minimize my resources. So I needed really a bare minimum messaging library. And that's when I started doing research, and I found out about MQTT. It's just a messaging library. It's just an IoT connectivity protocol. And it's been around for a while. It's been around since 1999. And it was really developed when engineers in remote locations, I think in Africa, needed a solution that allowed for minimal battery loss and minimal bandwidth when they were connecting sensors from oil pipelines over satellite connections that were really flaky. And I could really give you a whole talk about MQTT because I really love it now. But I just really want to highlight the things that I thought were most awesome. So it's a publish-subscribe architecture, and that just means it has client and it has a central broker. And when a client connects to the broker, it subscribes to topics. And then when other devices send out messages with that topic, then they can be forwarded to those clients that are subscribed. And what's really cool is that the publisher and subscribers don't need to know about each other, and they don't have to run at the same time. So operations on both components operations on both components aren't halted during the publishing or receiving. So things can go offline, and that's okay, because when it reconnects, it can still receive those messages. It's super lightweight, so it's just transport over TCP. And it has a 2-byte overhead, which is really minimal. Every bit in that package is carefully crafted to reduce the data transmitted over the network. And it means that in comparison to HTTP protocol, it doesn't load the network with the transfer information, which is only necessary for the functioning of the protocol. It's just really about sending those messages and not keeping the protocol running. The spec is really short and readable. It uses simple verbs to describe actions. Basically, there's 5 verbs in MQTT: connect, disconnect, publish, and subscribe, and ping. And that's it. So with that information, I needed to rework my server, my client and my server from Socket.io to using MQTT. This is like the basic like schema of my my flow of information. So they have the web app on the left. It publishes like a program Rainbow, and I have my clothing on the right, and it subscribes. It subscribes to topic light, and then when the app publishes on that topic, like the string rainbow, then that gets sent to my shirt, and then it knows to show the rainbow program, and that's all mediated through the broker. So first thing, I set up the web client. And yeah, you can use MQTT in the browser. There's MQTT.js, and it's just a client library. It's written in JavaScript. It can be used on Node, and it can also be used in the browser. So I just want to show you a little bit of code. And really, it's only a few lines. So you include the library. Then you also create, Then you also create a client, and you just put the address of where the broker is located in there, the URL. And then I can have on my DOM, I can have like a button that's a rainbow button. And so when it presses it, I can have it that it sends a message that it just publishes to the topic lights, and then it includes the name rainbow, and then it just includes that there, so it knows the payload is rainbow, and then it can send that to the broker and then onto the hardware. And then next, setting up the Arduino clients, because there's a microcontroller in each of these pieces. This is, C++ Arduino code, but it's not too scary. It's very similar. You just include the MQTT client library, and then you just, again, you connect to where the broker is on the web, and then for the hardware, I added in a step where you subscribe to what topic you want. So I have lights. And then I just include a program that it knows when it gets a message that is subscribed to, then it knows it needs to do something there. And if you're not familiar with Arduinos are basically just running a loop the whole time. So I just have in here a loop. So it's just always kind of waiting to, if it gets a message, then it can interpret it. And then next, I needed to set up my MQTT broker. Everything was going really smoothly. So you might imagine that I had a little hiccup here because I had my server deployed on Heroku, which is great. It's easy. CLI tool is really easy to deploy my code, and it just works. But there was a small hiccup because I needed a certain port access. For MQTT, the general protocol is 1883, but Heroku, in its simplicity, doesn't allow you port access. So I couldn't deploy my own MQTT broker. So yeah, the ports weren't accessible. And I also wasn't ready to leave Heroku because I'm not a DevOps, not the most comfortable person with DevOps, so I was kind of worried about ramping that up and doing that myself. So I found a workaround, and I started looking for like an external MQTT broker as a service. And I found one. So there's this site called Shifter.io. It's just an IoT platform, a prototyping platform. It's completely free. It's easy to set up. You just sign up and you get a key and token, and you're ready to go. And then it doesn't seem to limit the number of messages per minute. Some of them do. And I got it working, and I was happy, but I wasn't ecstatic. Relying on a small external broker service was not optimal for me because I'm putting my trust in someone else. And it was also a small service. I couldn't find much of information about it. It said it was free, but was it going to be free forever? And I kind of just didn't like giving up that control to something I didn't kind of trust. So I wanted to find another solution. And side note, I'm a huge BoJack fan, so if you want to chat about BoJack in the latest season, find me after the talk. I love to talk about BoJack. So yeah, my third iteration was I wanted to build my own MQTT broker. And to do that, I needed to decided to move from Heroku to DigitalOcean. You can move to other ones, but I just chose DigitalOcean. And to implement the broker, I use this library called 80s. It's a really great library. And for my application, I just have this really small Express server that's serving my site. And then I just could embed my broker into that current setup, which I really like. So there was really a minimal configuration change for me. So again, just a few more lines of code. So of course, I needed to include the library, and then I needed to create a MQTT server for handling those MQTT requests over the port 1883. Then I have my server. Like I said, I was just integrating this into what was already serving the web app. And then you just add on to the HTTP server, and it handles the MQTT over WebSockets. So it handles those requests, just through the HTTP server, which I thought was really cool that you could just kind of integrate them all together. So awesome! I conquered my DevOps fears, and it worked. Also, side note, since I work at Microsoft, I feel like I can show this GIFs as much as I want now, because I've always loved Bomber and early Microsoft GIFs, and now I'm just going to go crazy with them because I can say I work at Microsoft. So it's pretty. I'm going to totally jinx myself, but I feel like it's pretty rock solid now. Watch it all crash. So I thought I was, I should be done, right? Yeah, no. The last thing I did, I want to just make it super, super rock solid. So I upgraded the microcontroller. And I'll tell you why. So I changed to this another Adafruit Adreno called the Feather M0 Wi-Fi. And I did that because it has low power management, so it should be easier on my small batteries that I use to power this. But the main reason is it has a separate Wi-Fi module. So it doesn't have, that means that it doesn't have to yield all the time to the Wi-Fi cord. They're not shared. So it's just on a separate chip, so you get full reign of the processor and the timing. The only really downside for me is, you get really high-speed, reliable Wi-Fi. This has not really crashed since I've upgraded this. The downside is it is twice the cost. So if you want to have an idea, the Feather Hisa, the earlier one I used, was about 17 euros. This one's about 35 euros. So it's twice the cost, but it's 200% peace of mind for me, so it was worth it. So it's demo time. Some people have seen this talk before, so they've already been playing with it, but please feel free to go to flashylights.nl, which maybe I need to change to DE now because I live in Germany, but you can go there and we'll just bombard it with messages and see how it goes. So while you're checking that out, I just want to wrap things up and say that this was a really weird experiment to do as an introvert. Even though I'm on stage, I am a super introvert. I feel very awkward all the time. So attracting attention to me and actively seeking out people to interact with me is really outside of my comfort zone. And it was an experiment that really pushed me to deal with my own reactions to those interactions. But I really wanted to see if this could bring a momentary joy and delight to strangers by just not only having LEDs, which, come on, people love LEDs, but when they find out that they actually can control it, just giving them that extra bit of joy. And I think I accomplished that. It's really a lot, we're in the tech communities and we see a lot of cool things that are people building, but this is a side of tech that a lot of people on the streets of Amsterdam have not seen. So it was really cool just to interact with people, and then they see me and they don't expect me to be a software engineer, and it was just really kind of cool to talk to people and let them play with my clothing and give up that control. So I just wanted to say thank you. We can stay in touch. I'm Stephanie Coes on Twitter. Stephanie.lol is my website. And I have a bonus that I want to plug. I made up another little creation recently. It's a speech-to-image necklace. So I know there's not sound, but trust me, I'm saying awesome things, and I'm saying memes, and it's showing up on my screen. So I'm going to wear it maybe later today, at the party tomorrow, whatever. So you can come and just have me talk and then just not look at me and actually just look at my screen if you want. Yeah, so that's it. Thank you so much.